Look at a two-tailed hypothesis test. So the first question, 40% of customers in a cafe buy a cake. The cafe owner changes the cakes on offer. She takes a random sample of 50 customers, 14 buy cakes. Test at a 10% the hypothesis that the proportion of customers that buy cakes has changed. So our null hypothesis, what we start with, is the probability is 40%, and our alternative hypothesis is the probability is not 40%. So it's a two-tailed test, and we're going to assume that the null hypothesis is true, and we're going to look at our binomial expansion. N is 50, and the probability 0.4. So what is the chance of 14 or less? So what is the chance of 14 or less? A cake. If the null hypothesis is true, so distribution, binomial cumulative distribution for a variable, x is 14, n is 50, and the probability 0.4. So what's the chance? It's 5.4%. So it's 5.4% chance that it's going to be less than or equal to 14. So it is not meeting, it's in the acceptable region, or the acceptance region. In the acceptance region, 5.4 is bigger than 5. So there is not enough evidence. There is not enough evidence customers buying a cake has changed. A question for you to try. See if you can give it a go. So previously 70% into a shop, make a purchase. The shop owner takes a random sample of 40 and 33 make a purchase. Test at the 5% level of the significance, the hypothesis that the proportion of customers that make a purchase has changed. So the null hypothesis, what we start with, the probability is 70%. Hypothesis, it has changed. It's not 70%. So it's a two-tailed test. 2.5% for each tail. So we want to know if, so 70% of 40 will be 28. So we're at the top end. So we're going to work out the probability that x is less than or equal to 32. X is greater than or equal to 33 is 1 minus the probability that x is less than or equal to 32. So we're going to put 32 in and find the probability. So x is 32, n is 40, and the probability is 0.7. So we've got a 94% chance, 94.5%. 1 minus 94.5% is 5.5%. There is not enough evidence. We're looking for 2.5%. So 5.5% is greater than 2.5%. Evidence. support the hypothesis that the proportion conclusion, it's a good idea just to copy the text from the question. So there's not enough evidence to suggest the hypothesis customers that make a purchase has changed. And for the first question, there is not enough evidence to suggest the hypothesis the proportion of customers that buy cakes has changed.